Hello guys, good evening everyone. Welcome to Pantech Solutions and I warmly welcome you for the series Raspberry Pi Masterclass Day 10. So in this session we are going to see the project called Smart Energy Meter System using Raspberry Pi. Okay, so I hope some of the participants from Arduino Masterclass, so they may hear about this project. So here we are going to see a little bit different. Okay, so I'm warmly welcome you all, every respected professors and every students. So I hope you all are ready to attend the session. So if you are ready, please put I'm ready in your live chat. Okay. So same as like before going on to the session. So same as like there is an announcement. So attendance like will be available around 6:30 p.m. So once the session is completed, start filling up the attendance form. So until then, don't rush up for the attendance form. Okay. So good evening guys. So good evening Barani Dharan. Good evening and Dawood Basha. Good evening Shalini Vishwant. Good evening. Um, Venki, good evening. Hey Shalini, so a lot of participants are telling you ready. So I think you all excited. Okay, so we'll move on to the session. So first of all, in this session, we are going to see about like circuit design, and then we are going to see like calculation, like how to do the calculation for voltage and then current measurement. And third, we are going to see smart energy system, like how to build that say basic project. And finally, we are going to have a discussion Q&A, of course, tech news. Okay, so I hope you got it. So first of all, requirement, so like prerequisites for this course, the hardware such as additionally we are going to use MCP3008 IC, that is nothing but external analog to digital converter, and potential transformer, and then current transformer, and then signal conditioning circuit. Then two loads such as you can use bulb and switches, and in the signal conditioning circuit there are a lot of components like rectifiers, capacitors, load resistance, trim pot drivers, 5 volt Zener diode, and Berg strips, and then so those things. Okay, so those things are already present in that signal conditioning circuit. Okay, so let us go for the circuit. So first of all, here we have the circuit. Okay, we just drop like a schematic. Okay, so here first of all there is a power transformer. Okay, so before going on to the circuit, first of all you just see the hardware so that you'll have a better understanding. Okay, so first of all, here we have, I think Arduino participants may know about it, but anyhow, please listen to it, because I don't know whether am I telling like something differently or some extra knowledge about it. Okay, so please listen it carefully. So first of all, what is the main purpose of like calculating the power and those things? So whenever we are handling the electricity, the first thing we need to know like voltage and then current and then power, right? So these things, so without knowing voltage and then current, we can't able to calculate the power, because what is the formula for power? So that is nothing but P is equal to VI. So voltage multiples of current. Okay, so that is known as a power. So we can't able to calculate the power without knowing kind of like current or voltage. So first of all, what is our requirement? We need to measure the current and then voltage, right? So on that scenario, first of all, I think you may already have the sorry, that socket is there, no, 2 volt or 3 volt socket. So on the times, definitely it will come from like 3 volt, 230 volt or 240 volt. So like 222, 240 volt alternating current will come, right? So on the time, so you can't able to measure the current or voltage from the Raspberry Pi, because definitely it is high voltage, right? So 230 volt, even we itself we can't able to handle, but this Raspberry Pi is also can't able to handle that much power. So on that scenario, we need to step down, or we need to convert that 230 volt and then current rating into the voltage or the current which can be handled from the Raspberry Pi. Okay, so that's the conversion we need to do. Like 230 volt is already there, and same based on the load, they are going to be the current. So we are going to convert that kind of ratio into the 5 volt ratio with the which is compatible with the Raspberry Pi. Okay, so that's it here. Okay, so here first of all what we are going to do is, so I hope you all seeing the hardware. So on that here hardware, first of all we need potential transformer, and another main thing I wish to say, so whenever you are handling these kind of transformer and these kind of electric circuits, so please be careful, because it really having a great risk. Okay, so don't touch like this. Okay, because now the socket is unplugged, so that's why I'm just touching normally. Okay, so here we have potential transformer, and sorry, this one is current transformer and this one is potential transformer. Okay, so potential is nothing but voltage transformer. Okay, so we have two transformer, one is for current transformer and then for voltage transformer. Okay, so here first of all we need to do the step down. So step down in the sense, we know that in the socket we are getting 230 volt. Okay, so we can't use the 230 volt directly to our circuit. So first of all what we are going to do is we are going to do the step down. So this is like 9 volt. Okay, like 9 volt step down transformer. So what it's going to do, it's going to convert that 230 volt into the 9 volt. Okay, so in this line, in this yellow wire, this wires is going to have the step down voltage, that is mean by like kind of like 9 voltages. Okay, so on the 9 voltages, so it already have this 9 voltages. Okay, so after getting the 9 voltages, still it is in alternating current. Okay, so alternating current in the sense the current will be like sinusoidal wave. Okay, so that definitely is also going to be like sinusoidal. That is kind of alternating current. I hope you know who invented alternating current, right? So we have already discussed in the first session or third session, I think. So I know you know the answer. You just type your answers in your live chat. Okay, so other than that, so still it is in the alternating current of 9 volt, because it is only transferring the voltage or the kind of supply, like doing a step down. Okay, step down in the sense 230 volt to the 9 volt. Okay, so the function of this transformer is to doing the step down from 230 volt to the 9 volt. Okay, still now it is in a alternating, it is a like alternating current. Okay, so to convert that alternating current into the direct current, so we need to do we need to have the circuit. So I hope you know what is the circuit which is responsible for converting alternating current to the direct current. So which is nothing but kind of it is like with the help of the rectifier. Okay, so with the help of the rectifier we can able to convert that alternating current into the direct current. Okay, so here we have this two transformer. So to in the transformer it is converting already 230 volt to the 9 volt. After converting into the 9 volt, we need to do the like rectification. So because that will convert 9 volt alternating current into 9 volt direct current. So that's why we have the circuit with the bridge rectifier and then capacitor. So and after that we are going to have one trim port driver. Okay, trim port driver in the sense kind of like it will convert or it will be used to regulate or it will be used for tuning. Okay, so tuning purpose in the sense if you want to regulate or you want to change that trim port value to identify what is a kind of value based on our voltage which we are giving as an input. Okay, so here that is blue color one, that is kind of trim port driver which is used to adjust the voltage level. And then on the voltage side we have used one load resistance to have a certain load before we are applying a voltage or supply. And then we just dropped one like 5 volt Zener diode, because here we are using external ADC or our Raspberry Pi going to supply or going to have like kind of only 5 volt. Okay, so like maximum of 5 volt. So that's why we are just passing that into kind of like a Zener diode. Okay, so that is a 5 volt Zener diode. So and after that so from the Zener, so that's up to the connection. Okay, so that is the two parts. So one part is one part is for voltage and another part is for current. Okay, so so that's how the two parts. Okay, so on the two parts, so first of all on the left side, that is the voltage side, we are going to get the jumper wire. One is going to be the ground, so one end of the Zener diode is going to be the supply or the data, and another end going to be the ground, same as like for the voltage side. And still now we didn't get, yeah, only one answer, that is Edison. No, alternating current is invented by Nikola Tesla. Okay, so there are two parts. So first one is, this one is for current, and then this one is for sorry, this one is for current and this one is for voltage. And intermediate we have used the relay. So what is the purpose of relay here? So it is going to act like a switch. So for example, if I want to turn on this 230 volt bulb, so here we are using two bulbs in here. So if you want to turn it on or turn it off, this bulb or this load, so we need kind of relay kind of thing, so that we can able to kind of like we can able to, like if you are giving 5 volt to the from the Raspberry Pi to the relay, then that relay will be activated to pass this 230 volt to this loads. Okay, so that's the main purpose of using relay. So relay circuit is also given with the Raspberry Pi, so which contains a resistor and then diode and then transistor. Okay, so this circuit diagram which is detailedly given in this schematic. Okay, so here we have So first of all, there is a power transformer. Okay, so power in the sense, sorry, this is not a power, it is a voltage transformer. And then here there is a current transformer, which is each to both transformer is connected with rectifier with the capacitor, so that alternating current will be converted into a direct current. And we have used the 10K trim port driver to adjust the kind of voltage, like tuning, that kind of process. And then we have used the diode, or like here we have used the Zener diode, that is a 5 volt Zener diode in the final state of the two circuits. Okay, so which is connected with like two jumpers. So only one jumper you will get the voltage of current sensor or current sensing, and then in another pin you will get the voltage of voltage transformer. Okay, but in the values of 0 to 5 volt. Okay, it won't you won't get like kind of more than 5 volt, because now if it is showing 5 volt, it represents a 220 volt. If it is showing like 1.5 volt or 2.5 volt, means so it is only getting 120 volt, so something like that. So it will be leveled automatically, so that 0 represents 0 volt and 5 volt represent 230 volt or 240 volt. Okay, so that's up to the circuit. So after that, both circuit is like current transformer and potential transformer. So the supply should be given to the loads, right? So for giving those kind of supply to the loads, so we have used the relay connection. So on that relay, so there will be a like three main pins. One going to be the common pin, and another going to be like NO, that is normally open and then normally close. So for example, so normally close means, so it will be like this. Okay, so here there is a three wires, let us take. So this is normally close. Okay, so it will be look like this. So whenever you are making that relay to be in off condition, then this moving armature, it will shift to normally open to normally close, or so on the time, so it will be like open, so that on the time 230 volt won't pass there. Okay, so we need to choose the normally open, because whenever we are running the program, it should not be turned on initially itself. Okay, so that's why we are using a relay. So we have used in the especially of normally open and then common pin. So here we have a common pin which is obtained from the transformer, and here we have another pin, like another pin which we took from here. Okay, another end of the transformer. Okay, so this is NO. Okay, so normally open, which is connected with the two loads. Okay, so one is DS1 and another one is DS2. Okay, so I hope you got this. Okay, it is getting lagged. I think now it is fixed now. Okay, so let me continue. So I'm repeating again. So there are the two circuits. So one circuit is responsible for current calculation, and then second circuit which is responsible for voltage calculation, and then we have a relay. So relay circuit is to switch on the load or switch off the load. Okay, so for that load we have used the two lamps. So one is lamp 1 and then lamp 2. So intermediate we have the switch to switch between one load to the another load. Okay, so that's it. Okay, so I hope you got the circuit. So if you got the circuit, you just put I got the circuit in your live chat. Okay, so that's all about the circuits. So what we need to do, we discussed about IC is used for converting like analog to digital conversion. Okay, so before going on to the calculation, so first of all, we need to understand the like working of this MCP3008. So it is nothing but it going to return a decimal value. Guys, I'm not I'm not like I'm telling a lot of things which is not present in the slide, so please note down. Okay, so the output of the MCP3008 is going to be binary with the decimal, like binary is converted into a decimal, so it is like digital. So digital signal which is represented in the format of decimal numbers, which lies from 0 to 1023. Okay, so that 0 to 1023, how we can got it is like by measuring or by knowing the specification of analog to digital converter. So using the analog to digital converter, that a 10-bit analog to digital converter. So 2 power 10. So okay, so that's the value. Okay, so first of all, here 5 volt is equal to 1023. Okay, so the maximum, so which we have already seen. So 230 volt, like 0 to 230 volt is scaled to 0 to 5 volt in the Raspberry Pi, right? So same as like for 5 volt in the ADC, we will get the value of 1023. Okay, so we know about like 5 volt. So what is the 5 volt value? So we'll get 1023. Okay, so but now we need to calculate the scaling factor value. So for that, what we are going to do, we are going to measure it for 1 volt. So 1 volt is equal to 1023 divided by 5. Okay, so 1V is equal to 204, and calculating ADC voltage is equal to, so 2.26. So how we got this 2.26 means, so we have manually with the help of the multimeter across the circuit. Okay, so across the circuit, that is 2.26 multiples of 204, so that we'll get one calculated ADC voltage which we obtained from the ADC center. Okay, so and then what we need to do, we need to do the scaling, because so we know that so maximum voltage which is measured on that line, so that is 238 volt of the power socket which is present here. Okay, the junction box which is present here. So on that, x is equal to calculated ADC voltage divided by AC voltage, so which means so calculated ADC voltage which we know, that is 462 divided by 238. So okay, 238 is also measured in the line, across the line with the help of multimeter. Okay, we just measured it and we have calculated the x. So here what the x means, the factor which should be divided with the ADC value which we got. Okay, so that we'll get the approx scaled value of the voltage. So for example, if you are getting some of the ADC voltage like 1.94 means, so it may resembles like 230 volt in the power socket or voltage power socket. Okay, so same as like this left side for voltage calculation, same as like for right side we need to do for current calculation. For the current calculation, instead of measuring like current, or sorry, instead of measuring voltage across the diode and the line, we are going to measure the voltage across or current across the voltage and the line. Okay, so that's up to like 0.23 amps. So what we are going to do, we are going to perform the same operation but with 0.023. okay, you just compare left hand side with the right hand side. So calculated ADC voltage is equal to 0.23 multiples of 204, which is going to give the 46. And of course we are going to do the scaling. So for that, AC voltage is equal to calculated ADC voltage divided by x. So here we are going to substitute this 46. Okay, so 46 divided by 0.23, which means 200. So here for current calculation, we need to divide it with the 200. Okay, so for voltage calculation, so whatever the value which the ADC is giving to us, we are going to divide it by the factor called 1.94 for voltage, and we are going to divide it with 200 for the current measurement through with the value which is coming from the ADC. So while seeing the program, you will know. So you just remember these 2 points. One is 1.94 for voltage and 200 for current. Okay, so these two are the values. And now you just see the pinout of the Raspberry Pi. Okay, so on that Raspberry Pi, and before that, these are the calculation like resolution. So let us take like 1023. So those things we have already seen in the previous sessions. Okay, so I hope you got this. It's the basic circuit connection. This is the calculation here, and this is the connection we are given up to now. So this is like with the LCD. Here we are using without LCD. Okay, so that's it. Up to now, the connection is going to be the same. Okay, so the connection is given as per the circuit diagram which we have described there. Okay, so if you are seeing the hardware, you can able to understand. So I'm repeating the little bit connection after again. So like first of all, here we have potential transformer and then current transformer. Both is connected with one signal conditioning circuit. So this signal conditioning circuit, first of all, is going to convert that alternating current into the direct current, which is already stepped down from 230 volt to the 9 volt. And then we just use the trimper drivers for tuning the voltage which we obtained, and then Zener diode for regulating that. Okay, so like to pass this in the single side, one end to be the ground and another going to be the data. So here we have the two data for voltage as well as the current, and intermediate we have like relay circuit. So relay circuit, that is going to be also three data. So first one is VCC, and then ground, and then data. Okay, so three things are also given in like VCC, and then data is already given in the VCC pin here, because here we are not going to deploy kind of switching off the relays or switching on the relay. Okay, so that's up to here. So connection is given up to now. Okay, so what we are going to do, we are going to start our program. So let us go for the programming. Okay, so here we have a Raspberry Pi. So first of all, we'll open the program. So I hope you guys remember the MCP 3008 code which we have developed from the scratch with that register, sorry, with that like MOSI chip select. So those pin we have configured. These code which is already nothing but the code which we have seen in the day 4. Okay, so other than that, so first of all, we'll remove this. Some tables is not required here. Okay, so that's it. So first of all, what we need to do, so up to here the code going to be the same as like we have seen in the day 4th session. And here we have four pin names which is representing the SPI protocol control pins. One is clock, MISO, MOSI, and then chip select. So I think we have seen in the previous session also, right? So and after that we are making that MOSI to be like output, and then MISO going to be like input, and then a clock to be the output, as well as that CS chip select pin going to be the output. Okay, so that's up to the connection, that is up to the configuration of the GPIO pins. Okay, so and after that what we are going to do is kind of to measure the current and then voltage, and then we are going to calculate the power. Okay, so what we are going to do, first of all, we are just values from ADC, that is read ADC of 0 which resembles the 0th channel of MCP 3008, and read ADC of 1 resembles that first channel of the like ADC. Okay, so we are reading two values in the two variables, that is voltage raw and then current raw. And so this won't give the exact value of the voltage and then current. So we have already done some calculation to like by using some kind of constant value to convert into the voltage which is like it is available, or it is the exact thing. Okay, so that as per the calculation we have found that first x value, that is 1.8, and then second x value for calculating the current, that value going to be the 200, which is found with the help of the calculation which we have did before. Okay, so we are going to substitute, or we are going to divide that value with the voltage raw which is obtained from the ADC. So for example, volts is equal to voltage raw like slash like divided by 1.8, and to calculate the current by 200. Okay, which is obtained from the two ADC pins. And then to calculate the power is equal to volts multiples of amps. So like voltage and then current, we are going to multiply it to obtain the power. Okay, so after obtaining the power, so what is the unit of power? Okay, so if you know the answer, you just please put your answer, what is the unit of power? Okay, so here what we are doing again, so why here while loop of I less than 60, which means we're going to do the iteration for 60 seconds, because here we are going to measure the power in the unit of kilowatt per hour. Okay, so to measure it in kilowatt per hour, so we can't able to, this is the demonstration, right? So for this demonstration we can't run this complete program for 1 hour, right? So instead of that, what we are going to do, we are going to calculate it for 1 second. Okay, so we are going to calculate for, sorry, we are going to calculate it for 1 minute. So 1 minute it is nothing but 60 seconds. Okay, so we are going to calculate this parts into for 60 seconds, and we are going to measure each and every voltage again and again, and we are going to calculate the power. So and after calculating the power, we are going to identify the energy also. Okay, so here there is an energy which we have initialized with the certain variables. Okay, so and after that what we are going to do, like we are going to calculate like kilo hour something like that. Okay, so for what we did, so up to here, so it will iterate for 60 seconds. Okay, so it will iterate for 60 seconds. Okay, so we are getting the answer, that is a watt. It's exactly right. Okay, so that is a unit of watt. So for calculating the energy and all, we can't able to calculate the energy in the unit of different thing. So what we are going to do, we are going to calculate in the unit of kilowatt per hour. So what we did, we just iterated this code for like 60 seconds. Okay, so it will calculate the current and then voltage, and it will calculate the power, so something like that. So it will do continuously to have the some kind of energy value. Okay, so now we are obtaining the unit, or the value which is in the unit of like only for per minute. Okay, but we need for hour. So for what we are going to do, we are going to divide it with the number 60. Okay, so that we are going to get energy per hour. Okay, so now we are get only that energy per hour, like watts hour. Okay, in the unit of watt hour, but we need it in a unit of kilowatt hour. So what we are going to do, kilowatt hour is equal to energy per hour divided by 1000. So which means we are going to convert that value into the kilowatt hour unit. So that's it. So on the final state, we just printed that voltage, current, and then power, and then its format of volts, amps, and then kilo. Okay, so that's up to here. So what it, so just calculate the voltage and then current, and then we have calculated the power, and the main bonus is also waiting for internship participants, so I'll tell you later. So before that, that's up to here. So we'll see. So first of all, so the part, first of all, I'm going to run this program. So before running the program, I have this socket, right, 2-pin socket. So I'm going to plug it in to give the power supply to the circuit. So first of all, this is the 60 watts bulb. Okay, so first of all, it's going to glow. Then only it will it's going to calculate the current and then voltage and then power. Okay, give this connection. So initially it is on condition. So here in the program, run and then run. Okay, so first of all, it already took current and then voltage. Here we need to wait for like 1 minute, so that it will, first of all, it will take the current, and then it will take the kind of voltage, and then it will multiply to get the power value of power. So after getting the power, we need a energy. So energy can't be calculated within a second. Okay, so what we are going to do, we are going to iterate this loop for 60 seconds. So for 60 seconds, how much it's consuming? Okay, so that's why we are doing here. So energy is equal to power, and energy is equal to NR plus energy, which means, so we're going to add it. Okay, so we are going to add those things, and we are going to so here we have that is in the 60, right? So with the help of that divided by 60, so that it will have 60 value. So we are going to divide it, and we are going to get the value, and then we are going to convert into, like, in the unit of kilowatt per hour. Okay, so we'll just wait. So it's still printing dot. So after completing the dot, so after completing the 1 minute, so then it will display the kilowatt per hour. Okay, so what is the kilowatt per hour here, which we got? So I'll terminate the program. Okay, so kilowatt per hour is, that is 0.0716, that is up to like kilowatt per hour, that is kVh, and voltage is 226. I hope this is familiar, right? So it will be around 220 volt to 240. So we got 226 volt, and then current is 0.3 amps. Okay, and then power is, in the unit of kilowatt per hour, we got 0.0716. Okay, this is kilowatt per hour, not a watts. Okay, if it is, that's a watts, it will be around like 70 watts, because now two bulbs are glowing here, because one is representing like one bulb is representing, this is 60 watts, and this is the 10 watts bulb. Okay, we have used two bulbs, so that's why we got like 71, like 71, around 71 watts. Okay, so that's up to here. So what we did, we just gave the connection. We have designed one circuit, signal conditioning circuit, which is going to either 230 volt or that current value to the 5 volt ratio. And then in the program, like in the calculation, we have estimated that what is the x value and then y value by substituting the voltage and then current, which is already manually measured with the help of multimeter. So we have substituted the values, divided by 1.8 for the voltage and divided by 200 for current. And after that, we have calculated the power. So after that, it can't be calculated within the unit of kilowatt per hour by having an iteration. So that energy can be calculated by iterating for 1 minute, and then it will convert it into an hour. So and then to get in a kilowatt hour unit, we just mentioned, or we just did like divided it with 1000. Okay, so that will get the unit of kilowatt hour. Okay, hope you got this. So this is up to the basic of developing a certain circuit for voltage and then current measurement. And also, so it's time to release the source code bonus for internship participants. So for final year project, because this project is really worth for final year, mainly for all departments. And the first source code, that is source code for prepaid energy meter. Okay, so that source code is also going to be provided for internship participants. And also the second source code, which is like source code for power theft identification. Okay, so first of all, in the first source code, what it is, the mean prepaid energy meter project. So what it means, like we'll allocate some fees or amount to be paid, like 5 rupees. First of all, it will calculate the power, same as like which we did here, and then it will calculate the energy, and then it will calculate the fees, like how much time it is running or how much time it is consuming the power, what is the power value. So based on that, it will assign a fees, and finally after completing the complete iteration, then it will print you the message. So this is the bill, so like kind of automatic bill generation. And then So on the later on for internship, so they're going to learn that web page server, and then they're going to learn IoT concepts, right? So let's say like sending mail and those things. So with the help of this code and that code, so by doing the combination of these two codes, they can build or they can deploy a real-time prepaid energy meter, like paying the fees from the online, or paying kind of like not a real fees, just like a button. Okay, so by paying the fees or paying the bill, so it will automatically generate the bill and it will send a mail to each and every mobile phone users which having a certain ID. So that kind of huge project can be done with the help of these kind of project. Okay, so these two source code, so two final year project going to be provided for internship participants. I hope you will enjoy it. So if you will enjoy it, you just put I'm enjoying it in your live chat. Okay, and that's why I'm telling you to join on in Raspberry Pi masterclass, because you may get lot of knowledge about like your final year project. You can do your project by your own by completing these kind of courses, which includes artificial intelligence and Raspberry Pi, so that you can combine artificial intelligence with the hardware, so that it will be like AI with hardware. So the what is the benefits of like master classes? So you'll get the 30 days lecture video, so for each day that video will be released. And another main advantages is like for YouTube it is only for 15 days, whereas for internship it's going to be like 30 days. And source code, so while talking about the source code, you are going to get 25 plus source code. And if you are subscribed for artificial intelligence also, like combination of artificial intelligence course, artificial intelligence masterclass, as well as Raspberry Pi masterclass means, so you are getting like 30 to 60 projects. So you're going to deploy 60 projects in the Raspberry Pi. And finally bonus lectures also going to be given. Bonus lectures in the sense little bit source codes which is not present in the agenda. Okay, so you are going to get lot of benefit from this kind of master class. Okay, so if you are there, please register for the master class as soon as possible. Okay, so and then discussion. So first of all, while talking about the artificial intelligence, you may start your discussion, guys. So what you are thinking about artificial intelligence? Is that a risk, or is that going to be like our user friendly, or our friend, or our enemy? Okay, so you just type your suggestion or your opinion about artificial intelligence in your live chat. So I'm waiting for your answers. Okay, a lot of people have posted. I'm enjoying it. It's really great. Thank you for your phones. Okay, so the first, of course, the first answer going to be from Vishal Penule. A is machine that is able to perform tasks that require human intelligence and it learn things by itself. Yes, it's exactly right. As like Sophia, right? Yeah. Then Saran Vijay, his opinion is user friendly. Okay. Then Aravind, AI going to rule through the next few years in technology. Yes, of course, it's going to be. Akash Nayak, AI is machine that is able to perform tasks that require human intelligence and learn things by itself. Akash, don't copy paste the message, okay, which is replied from Vishal. Okay. Um, okay, Sirpa Prasad, that is very good. That is going to be very good future. Okay, so AI is future. Every technology has its own advantage and disadvantage. Abhishek goes, it's exactly right, which the answer I expected. That is, every technology is going to have like advantage as well as a disadvantage, because if you are taking any technology, for example, if you are taking a mobile phone, so there is a radiation scars is there. So there is a disadvantage, whereas if you are talking about the advantage, we are enjoying it, right? So and then we are gaining a lot of advantages from the mobile phone, right? So that's the thing. So there is a both advantage and disadvantage. We can't able to control the development of technologies, like whenever, even though it is affecting a lot, but we can't able to control the development of the technology. So that's the real fact. It's the main thing. So while talking about artificial intelligence specifically, so there is a certain like artificial intelligence circle. So inside that it's going to be have a machine learning. So inside that machine learning, so we are going to have a deep learning. So first of all, machine learning going to deal with both image as well as normal data. Artificial intelligence is nothing but kind of learning something from the kind of us like a human. Okay, so for example, let us take a Indian movie or Terminator or iRobot or Ex Machina. So there are a lot of movies are there. So anyhow, in every movie's climax, so definitely that artificial intelligence robot or a machine going to work badly, so that they'll destroy that AI. So that's the main like climax of every AI based movies, right? So that's about here. So first of all, it should observe. Okay, so first of all, it may be sense. So as like a human, you just imitate like a human. For example, like visualizing, like recognizing. For example, I can able to recognize this is the pen drive, and I can able to recognize this is the screwdriver. So recognizing, vision based knowledge, and hearing based knowledge. So for the microphone, which we can able to deploy, and for speaking, so you can put up the speakers, and like sensing, so like smell, taste, and touching, feel. Those things can be sensed with the help of like kind of sensors. And then movement, like physical movement can be done with the help of motors. And then like our energy as can be given like with the help of the batteries. So that can be like that is kind of basic robotics. But other than that, we are going to provide a lot of intelligence to recognize something, some objects, and to make a decision by itself. Okay, so that's the main thing. So for example, if you have watched an Indian movie, so on that movie, the doctor or doctor will tell you tell that bot to pick up the gun. So instead of picking up the gun, so it will pick up the bomb, right? So but whereas in the chitty, whereas if you're taking a chitty, so it is very smart and very fast, as well as very knowledgeable, right? So on the time, that classification and those kind of recognition capability is given to the robot in a high efficient way. Okay, so like classification and the movement, physical movement, and those things is given kind of lot of things. Okay, so that technology improvement can't be controlled. Okay, so because it is still it is increasing a lot. Instead of that, to avoid the lot of risk, we need to handle that kind of advanced technology in a safe manner. So for example, let us I hope AI participants may know about this news. So on before 3 to 4 years, Facebook already has some kind of some kind of artificial intelligence bots. So one is Bob, and then another one is Alice. So automatically on one certain day, so that both artificial intelligence spoke with each other with having a jumbled letters of words. So on the time, every scientist or research to like decode what is the conversation which is that did by both robots. But on the time, they can't able to identify what is the text or what is the meaning of that certain kind of word. Okay, if you want to know the chat, you just put Facebook artificial intelligence speak each other the conversation. Okay, so if you just put, you can able to see it, because that words are completely jumbled, like I do thing, I do eat it, so something like that. It's very different. Okay, so that kind of risk is also there. So on the time, so there is no way to other than that to shut down that kind of artificial intelligence bot. So on the time, they just simply shut down that. Okay, so that's up to here. Okay, so for each and every technology is going to be like advantage and the disadvantage. We can't able to control the improvement or development of the technology, so only way is to handle it in a safe manner. Okay, so the branches in artificial intelligence, there are a lot of things. So the main familiar thing is machine learning. So machine learning going to handle like raw data, like integer and float points, like sensors, so the data which is received from the sensors, as well as the image data in the format of Excel. So that kind of thing it also can do to handle like image kind of classification, machine learning algorithm, and deep learning, especially for image based classification, which is be like a real time camera based on real time camera. And then while talking about NLP, so that is not like natural language processing, which will be helpful for designing the chatbots, voice assistants like Google, Amazon Alexa, and Apple Siri. So that kind of chatbots and that kind of voice and text-based conversation or chat can be developed with the help of natural language processing. Okay, so that's all about the artificial intelligence discussion. And tomorrow we are going to see a little bit science with the kinetic energy versus the potential energy on the tomorrow's discussion. I hope you will prepare those things. Okay, so tech news of day. So I hope you may heard about this news. That is like Trump's account was locked. Like even though if you are taking like a Facebook or any social media, so I'm not here to projecting that Trump and those things. I'm here to explore, or I'm here to tell you about the technologies which is behind it. Actually, whatever like the data, the content which is kind of which contains kind of violation, So that can also be automatically detected with the help of the algorithm such as artificial intelligence. So in the artificial intelligence, there are machine learning is there. So with the help of that machine learning, we can able to detect the fake news or violence news or something like that. Okay, so like there are a lot of violent messages or violent kind of posters are there. So with the help of the artificial intelligence, because if you let us assume, so there is one Facebook. Let us take a Facebook industry. So if someone is posted one violated messages, okay, so if let us take let us take a manpower, okay, so we may have millions of Facebook users are there. So for millions of Facebook users, we may have to drop millions of employees to check each and every messages manually. It is really impossible. So in the time, that kind of artificial intelligence based algorithm is playing a role to detect what is kind of violent messages or violent posts or kind of like different kind of vulnerability activities. So those things can be automatically identified within the algorithm, like artificial intelligence algorithm. So as same as like the Trump's account is also locked by the Twitter, and also Facebook and Instagram also Trump banned Trump for 24 hours by having by seeing the kind of violent message or post. Okay, so then the Facebook newsroom also that they just tweeted like we have assessed two policy violation against President Trump's page, which will result in 24 hours feature block, meaning he lost the ability to post on the platform during that time. So for 24 hours, the account was being banned by the Facebook and then Instagram for like Facebook, Instagram, and then Twitter also. Okay, so that is the behind thing which is already there. That is kind of algorithms like artificial intelligence algorithm. Okay, so that's why I'm insisting you to learn artificial intelligence algorithm. So if you don't know about anything about artificial intelligence and if you don't know about any basic programming, please join with us on internship. So AI masterclass, which is going to provide a lot of information about AI, where where we have discussed about a lot of artificial intelligence news as well as a lot of final year project source code like 25 plus pro source code, which completely on hands-on experience, because that artificial intelligence course doesn't require any other hardware. So instead of that, you can run your artificial intelligence source code in your laptop itself. Okay, so that's the main advantage of that course versus this course. Okay, so but if you are already subscribed for artificial intelligence, you just purchase for Raspberry Pi masterclass also, and you just combine both artificial intelligence masterclass as well as the Raspberry Pi masterclass, so that you can able to deploy artificial intelligence algorithm in the hardware. Okay, so that will be really great. So that kind of masterclass link is given in the description below. Please check it out. So first link, which is described about like Raspberry Pi masterclass, and below if you just scroll down, you can able to see the masterclass registration link for artificial intelligence, MATLAB masterclass, Simulink masterclass, Arduino masterclass, Raspberry Pi masterclass, and etc. Okay, so if you want to register, please register as soon as possible. Okay, so Vishal Panuli, will you teach AI? Yes, of course, I taught AI because like I started, like I'm just working on artificial intelligence, so I just taught that artificial intelligence. Actually, artificial intelligence masterclass is completed. Okay, if you want to join now, you can join now. Okay, so I have already we have already included all videos here. Okay, so there are other courses also like brain computer interface, Simulink, MATLAB, Arduino, and then Raspberry Pi. So if you see here, artificial intelligence is here. So if you see here, like introduction to artificial intelligence, which is already taught by myself, like we will have up to 5 days, which can be a session with having a clear explanation with the hands-on experience. Okay, you can definitely will feel the hands-on experience. Okay, so I hope you know this guy, right? So this is nothing but that's me. Okay, so I just taught that one. Okay, so those things. Okay, so it will be very great. So you just please register for this session. So it will be very helpful for you. So artificial intelligence is going to be a future, so it will be definitely helpful for your career also. This artificial intelligence link is also given in the description below. If you want to register, please register as soon as possible. Okay, so finally we are in the Q&A. Okay, so definitely we'll discuss about the Q&A. So you can ask your questions, guys. So on the left side here we are seeing like up to like 30-day sessions like artificial intelligence 19. So the projects such as Python, so installing Python and basic Python programming, introduction to computer vision and libraries, and moving object detection using OpenCV, and object tracking based on color using OpenCV, face recognition using OpenCV, face emotion recognition using OpenCV, and introduction to deep learning and its libraries, and deep learning algorithm and designing neural network and real-time object recognition, hand gesture recognition, leaf disease detection, character recognition using CNN, label reading using OCR, that is optical character recognition, attendance system using face recognition using deep learning and machine learning, and vehicle detection and tracking. So with the help of machine learning trained model, and license plate recognition, drowsiness detection, and then road sign recognition, and machine learning, like overview on machine learning and evaluating and deploying machine learning algorithms, and the projects such as fake news detection and AI snake game using reinforcement learning, natural language processing, and then title generation from the paragraph using natural language processing, speech emotion lesson analysis using NLP, and AI cloud. So there are a lot of clouds we have explored there, so like Imaga, AWS knowledge, and finally we have discussed about like AI hardware, so which will describe you about like we have introduced a lot of the hardware there. We have a very great discussion on the AI hardware. Okay, so these are all about AI agenda. So if you want to register, please register as soon as possible. The link is given in the description. Okay. What is the difference between the Orange Pi and then Raspberry Pi? Actually, while talking about the Orange Pi, it is not much great than the Raspberry Pi, because there are a lot of user interface and user experience. It's really great in Raspberry Pi. So it's my suggestion to go for only Raspberry Pi. Okay. And if you want to spend more, if it is affordable for you to spend more money, you can go for Jetson Nano. It will be very great for higher other applications. Okay, guys, so it's time to have an end of the session. There is not that much questions here in the session. Okay, so finally, first of all, I would like to thank each and every participants who have attended the session. So if you want to know about the course, please visit learn.pantechsolutions.net and don't bother about the price which is described there. Okay, so because the actual price is given in the description below. Okay, so you just click the registration link which is given in the description below to register the certain master class, because in the master class you are going to avail a lot of knowledge as like a practical and hands-on experience. And then if you want to know about like product or projects, like if you want to like made a projects, so then you can go visit www.pantechsolutions.net, and the quote of the day: we cannot solve the problem with the same thinking we used to create them. Okay, so which is said by Albert Einstein. So like so there is a word, so you can't expect same thing, or you can't able to like expect different results by doing the same thing. Okay, but for different results you need to do different kind of actions. So same as like this. So how the problem is created, so on that one thinking, so you can't able to attain the solution by having the same thinking. So instead of that, you need to have kind of wide variety of scattered based thinking, so that you can able to fix that kind of problems. Okay, so I hope you got this. So thank you so much, guys. Thank you much for attending the session. And so we are in the 10th day, so only 5 days remaining. So definitely I'm telling you, so 5 days is not enough. It's not going to be enough for internship, sorry, for gaining a lot of knowledges in Raspberry Pi. So instead of that, you just please go for Raspberry Pi masterclass, so that will be very beneficial for you for in your career also. Okay, so because this is going to be our future technology, right? So definitely it will be very great to handle those kind of experience. Okay, so thank you so much. Thank you once again. So it's me, Sanjay. Until then, bye. We'll see you on the tomorrow session.